Here is the 6.5 Goal 2 Operations with radicals. In this part of the 6.5 section, we are multiplying radicals, adding and subtracting radicals, multiplying binomial radical expressions, and then simplifying fractions with radicals in the denominator with a binomial in the denominator. I'll show you what that is in a little bit. All right, so the first thing we're doing is we're just multiplying radicals. Basically, it's the same as simplifying, but you've got two radicals rather than just one. Likewise, it's the same thing. And the reason is because when you have two radicals, it's the same as them both being under one radical, as long as the radicals are the same. So therefore, you have the square root of AB. So what I'm saying by that is I have a 6 and a 4 on the outside. I know those automatically are on the outside. Everything that's underneath both radicals would be on the inside because you're multiplying, and so it's just like this situation. So what I'm going to do is I'm going to multiply, but I'm actually not going to multiply. I'm going to factor instead. So here I have 3 2's, 2 times 2 times 2, and then I have another 2. So I actually have 2 to the 4th power underneath the radical. Here I have 4 c's, because I have a c cubed times another c, so there's 4 of them. Here I have 8 d's. Now, just like simplifying the radical, you can go ahead and look at how many factors you have of each thing, taking out an even number since the index is 2. So this means I have a 2 squared on the outside. So not only do I have a 6, a 4, and I also have another 4, or 2 squared. So 6 times 4 times another 4. Oops. Here I have 4 c's, so that can come out as 2 c's. Here I have 8 d's, so that comes out as 4 of those, and nothing left underneath. So when I'm done, I have that is 16 times 6, which is, let's see, 16 times 6 would be, or 24 times 4, either way is that 96. C squared d to the 4th. So that's how you simplify when you're multiplying. Let's do the next one. Very similar to that. We've got 2 times 3 on the outside. On the inside of the 4th root, I have, again, 8 and a 2. They happen to put the same numbers out, but let's go with 2 to the 4th, x to the 8th, y to the 4th. Again, very nice because it doesn't have any odd number of radicals, or excuse me, powers, and so 4 goes into all of those, so that's kind of nice. So you got a 2, a 3, a single 2, because 2 to the 4th root is just 2, x to the 2nd, 8 divided by 4 is 2, and then y to the 1st. So my answer is 12 x squared y. Okay, so just work those through and try to get those to be as simple as possible. Okay, so here's the next example 4. This time we're adding radicals. Adding radicals is not the same as multiplying radicals. You cannot just add the radical. You cannot add what's inside. Basically what this is unlike radicals at this point. Even though they're the same power or the same radical, the same index, you cannot just add what's inside. It's like saying, this is like saying at this point, 4x plus 3y. 4 times the square root of 8 plus 3 times the square root of 50 is not the same. They are not like. Okay, so what we can do though, we can simplify this one. It looks like it's simplifiable. So it's 4 times 2 square root of 2, or 8 square root of 2. 8 is 4 times 2, and the square root of 4 is 2. That's how I got that. This one is plus 3 times the square root of 25 times the square root of 2, or 3 times 5, or 15 square root of 2. Now we've just found out that they actually are like. We have, this is like saying 8x plus 15x. It's the same idea. So since this is 23x, this is going to be just 23 square root of 2. Because what you're doing is you're adding 8 square roots of 2 plus 15 square roots of 2, which is 23 square roots of 2. You do not add the radicals. You're adding the coefficients in front of the radicals just like you would add the coefficients in front of a variable. Okay, this one here you've got 5 times 2 square root of 3, or 10 square root of 3. This one you have 2 times, this is the square root of 9, which is 3 times the square root of 3, or 6 square root of 3. This one, 64 goes into there twice, so it's minus 8 square root of 2. If you notice here that the two terms that are like are 10 square root of 3 and 6 square root of 3. The 8 square root of 2 is not like them, so our answer is 16 square root of 3 minus 8 square root of 2. That's as simple as it gets. You cannot add the square root of 3's and the square root of 2's. They are not like. So when you're adding radicals, make sure you are only adding like radicals. Okay, in this example, we have, it's like a binomial times another binomial. So what we're doing is we're foiling. So the first term's multiplied, I end up with 12 square root of 15. 6 times 2 is 12. Square root of 3 times square root of 5 is square root of 15. The outside radicals, 6 square root of 3 times 4 square root of 2 is plus 24 square root of 6. The inside ones, we end up with minus 10 square root of 5. The last ones are minus 20 square root of 2. If you notice that none of these have like radicals, the square root of 15, square root of 6, square root of 5, square root of 2 are not like. You cannot add those together. That is my final answer. All right, here's the second one. We've got the square root of 7 times the square root of, 7 square root of 2 times 7 square root of 2. That's 49 square root of 4, or 2 times 49, which is 98. So our first terms are 98. Our outside terms, 7 times 3 is 21, so plus 21. Square root of 2 times square root of 3 is the square root of 6. The inside terms, we have negative 3 times 7 is negative 21, square root of 6. Negative 3 times positive 3 is negative 9, square root of 3 times square root of 3 is 3, so that ends up to be 27. Now, these are called conjugates of each other because they cancel the middles out. The middle radicals cancel out, so we end up with 98 minus 27, which is 71 for our final answer. So all you're doing when you're multiplying binomial radicals, you're just foiling. Now, this is really similar to simplifying a fraction with a radical in the denominator, except this time we are going to multiply by what we call the conjugate, which is the square root of 5 plus 1. It's very, very similar to multiplying the top and bottom by the conjugate when you're doing complex numbers. All right, so when I FOIL the denominator, I end up with square root of 5 times square root of 5 is 5. Inside, outside add up to 0, and then minus 1. So my final denominator is 4. The numerator I'm going to distribute. Now, the only problem with this, I don't necessarily need to distribute because 2 square root of 5 plus 2, if I left it by not distributing, the 2 actually goes into 4 twice. So my final answer is the square root of 5 plus 1 over 2. So I have a factor in the top that's the same as a factor in the bottom. I can cancel those. The second one I'm going to multiply by 3 plus the square root of 2, top and bottom. Multiply, I end up with 9. Negative 2, square root of 2 times positive is negative 2, so that the denominator is 7. Distribute the numerator, I end up with 15 plus 5 square root of 2. And that's my final answer. So there are some tricks to this that you need to practice. You're going to need to practice, check your answers, and make sure you know what you're doing wrong. Good luck.